Working?
Yep.
Okay. So I'm Gary Lewis from Bio-Active Emissions Farming, and we're going through a presentation here with Jared and the employees. The most important thing for a farmer to understand is plant physiology. Is that, how do plants feel? As a mammal, when you have pneumonia, you know how a cow feels. But how do you know how a plant feels when you change its physiology to breathe in a lot of air through this lung? So the leaf is a lung in reverse to mine. So a leaf is taking in CO2 and giving off oxygen, and I'm taking in oxygen, giving off CO2 in my lungs. So it's exactly opposite. The root is a water pump, so that's the heart, and that's what's pumping water from the soil up into the leaf, and you got to have the heart pumping properly. And then around that root system is the stomach. That's where the microbiome is. That's where the microbes are extracting nutrients from the soil and bringing it to the plant and up into the plant. So plants don't extract, the copper, iron, and zinc and magnesium. Microbes do, and the microbes need sugar and energy in order to do that on this side. But what's happening when you put NPK and S on and all of the zinc and copper and iron and magnesium is because the stomach is not working, the heart's not working, you're not really efficiently pumping water up into this plant, is trying to digest the ammonium phosphate, and ammonium is positively charged, so it kicks off 3 hydrogens into your soil. So if you're very acidic soil, it'll get very acid, or if you're very alkaline soil, you don't have any sugar there for microbes to breathe out CO2 to soften that soil, because that soil can be very hard and compacted. So this system is taking up chloride because ammonium is positively charged, and it's all positive and negative charges. So ammonium feeding causes the plant to take chloride and phosphorus up with that ammonium, causing the leaf to be negatively charged. So CO2 is negatively charged, so a negatively charged leaf is not going to take it in very well. At 23 degrees Celsius, it stops carboxylizing, it stops taking in CO2, then it starts giving off steam.
That's for any plant?
Any plant, there's variabilities. Like corn has an ability to go to 30 degrees with fertilizer, and we may help it go to 40, you see?
Yeah.
Because this side here is when it has a positively charged leaf, because when it's nitrate feeding, nitrate is negatively charged.
Mm-hmm.
And nitrate takes in copper, iron, zinc, magnesium, and all the positively charged cations that are on your soil test easier, to make the leaf positively charged to attract CO2. So this plant is in maximum mode of making sugar and using the sun at full strength up to 30 degrees or 40 degrees on corn.
Mm-hmm. So in your opinion on wheat, what's the heat?
23 degrees Celsius, wheat will stop photosynthesizing. And wheat, we may go to 30, okay?
Okay.
Corn would be 30, and we're to possibly 40.
Yeah.
And that's just all about, if you go back to where, just go one more, no, where were you there? You're at the, right here. Okay, so this is in this is what I've been studying and reading for the last 20 years. Is plant physiology. It's a German scientist that compiled all of this experiments at that time about how plants feel. Put too much ammonium on, what does a plant do? Put on too much zinc, what does a plant have to do to counteract it? And so this here, just go back, Todd, to the one you're at. This is from this book this year. Stay at that graph right here. Nitrate feeding, okay? Takes in 212 potassium, calcium, magnesium, and all the positively charged things, 212. So if you're feeding cattle, what do you want to buy? Go and buy minerals, or do you want to just have it in the feed? Your choice,
Obviously the feed.
Yeah, and so if you're ammonium feeding, 120 nutritions in that feed. So you got cows that don't breed, you have animals that don't express their genetics, all this kind of thing when you feed them this, and it's high in phosphorus and sulfur and chloride. You see? Organic acids coming out into your soil to correct your soil, or 59 of them.
So with the negatively charged NO3, that's
natural in your soil. If you don't put any fertilizer on, you go and do a soil test, it says it has nitrate.
Yeah.
And what are you buying? Ammonium phosphate, right?
Yeah.
Switching your plants onto this, and then they have slow release nitrogen they're going to sell you.
Yeah.
And you know what that does? That kills all the microbes around the root, so so that they don't feed on that nitrogen and convert it into nitrate, eh? But nitrate and protein feeding, so I'm not really putting on any nitrate, it's just naturally in the soil, plus I'm protein feeding, so microbes make proteins.
Yeah.
And they take nitrogen from the air, and they're making their DNA strip, so they have a DNA strip that has zinc and copper and iron and magnesium on their DNA strip. They can go right to the root and slip in and give the plant protein and minerals, eh? Okay?
You know, that's one thing critical to understand is protein. You know, Gary's pushing 22% protein on his durum down south there. Hasn't had any fertilizer for 20 years now.
Yeah.
We're getting 20% protein plus. We're not putting on any N.
Yeah.
It's coming from
somewhere.
What about a normal wheat?
And normal, normal wheats too, like red wheat or durum. You know, they're same makeup. You'll get high protein, and you have to get enough microbiome from your tractor beside the seed at the startup, and that's where it's important that we have it strong enough in this fusion tank, this carbon water, so when you're going over, there's a whole bunch of new microbes there that actually fix nitrogen. And so the ones that come from diesel fuel are in my stomach, the same ones, and they're the ones that actually worked with plants millions of years ago, and they're amazing. They stay alive, and they're going through the combustion, and they come back alive again. And you pay a lot of money to go and buy these biological stimulants, but we're empowering you on this farm to reculture and build more of these, and they reproduce very fast if you have the right conditions. They love diesel fuel.
So are you familiar with the product that Black Earth produces?
I've heard of all different kinds of biochars.
They do an acid product.
Yeah.
Which kind of.
Yeah, it's a fulvic acid.
My brother's father-in-law actually runs that plant.
I see. Okay.
And apparently it does kind of the same thing.
It does.
It releases, makes the ground release
Yeah.
nutrients that you're not
And that's
accessing.
they're washing that out of coal layers, right?
Yeah.
Yeah. And so what's diesel fuel?
Well,
What's
it's
coal?
Fuel.
Yeah, they're both fuel. They're both hydrocarbons,
Yeah.
and they're relying on the poor oxidized layers of coal, and they're washing that out to get this humic fulvic acid, and they sell it to how much they pay? How much you pay for that? Quite a bit of money.
Like 20,000 a tote,
20,000 a tote.
pretty much.
And so you know what? You're making this for free.
And that's liquid.
Yeah.
Same thing.
Hmm.
Very expensive.
It's expensive.
And that's exactly what you're making is humic fulvic acid.
Yeah, so it's actually pretty similar, just a different concept.
And this is freshly made right from the piston of the engine. There's probably no microbes in this product that he's washing out of coal. Probably not.
Don't know that much about it. I was just wondering how similar
Yeah.
it is to, because kind of your explanation of
Yeah.
how it works on the plant.
It's quite similar.
Sounds very
There's a lot of natural products out there, but your diesel is like 400, 500 horsepower in the front of this dinosaur that you're driving with a stomach on it, and all that's, you can imagine it pounding into this rich amount of microbes that are reproducing. Well, and this nanocarbon speeds up microbes to do their process faster. That's what this is. And also on your high clearance sprayer, the reason why we put it in the high clearance sprayer is it can increase photosynthesis 30 to 50%. And what this is saying is this a nanocarbon tube? It's a billionth of a meter in size. The microbes put their DNA on it from the stuff we deliver to you, and that allows it to slip into the photocell and helps it use ultraviolet light and near infrared light, and that helps the plant photosynthesize more, right? So that's why we want to save this and reculture it and spray it onto your plants. Okay. So this is how a leaf works. This is a lung of a plant, and you want to have it positively charged, or do you want to have it negatively charged? So this is at 23 degrees Celsius. When the leaf is negatively charged, it starts to decarboxylize, start to smoke, gives it off vapor. That's why the leaves go on 23 degrees Celsius. If you have it positively charged, this positive charge is attracting this negative CO2 in, so the wind is going in, up to 30 degrees maybe, or I don't know exactly how much more, but it's all about carboxylizing and decarboxylizing is what I talked to you about. As far as what CO2 can do in my blood to control pH and all that kind of thing. The same thing is going on inside of a leaf or a gill of a fish or whatever. It's important. pH is important, but this has the ability to kind of control pH and keep it in the form that keeps attracting the CO2 in to the leaf, because this has a lot of zinc and copper and iron and magnesium, just like what that chart shows.
Yeah.
So it's important to manage your plant physiology so it's using the sun and not this fossil fuel energy of the fertilizer, because it's a switch.
Yeah.
Gotta be open-minded, you gotta think it through from beginning to
Oh,
end.
yeah.
Yeah.
Does this change heat unit requirements at all
Unit requirements of
for crops? Like, cause it can go up to, wheat can now go up to 30 degrees and keep photosynthesizing. Does that now take up the minimum heat requirement for the crop?
Yeah, like as far as the heat units for summer, I would say that if you had a colder summer, you would probably, have it so that the it's taking the energy from the sun. So if you had really cold days,
Yeah.
you're needing to wait until the heat of the summer comes. And a lot of times, if you have a really cold spring, our crops are putting their roots in. They're not really advancing on their shoots, so you gotta be prepared for how our crops look. If it's really hot, boom, everything goes right through its stages, and that's the way we've seen it, isn't it? Some years, if it's really cloudy, cold, it's sitting there. But if you go dig up the roots, that plant is, building large roots and putting a lot of sugar there. And then when it turns hot, everything from the soil that it pumped there, it quickly goes and it heads and it fills every grain. And we have very heavy grain, 65 pounds a bushel of wheat or durum or whatever, right? And oats are extremely heavy, and the plant actually knows how many seeds to set up by its interaction with that microbiome.
Okay.
So that's where it's important to put out enough seed, because our plants don't stool. With fertilizer, it tends to stool and a lot of suckers, where ours will put up about 3 mother heads, and that's where you have kind of control of the population by how much seed you plant. Okay.
So you want to plant, you want to seed kind of later in the year then?
Well, it doesn't have to be.
Doesn't have to be?
It is. I do believe, though, a warmer soil, the microbes are ready to go quicker if it's warmer. But we've had people do winter wheat down in the U.S. I've planted most people would plant winter wheat in September.
Yeah.
And we set up a system in Soda Springs, Idaho. It's like 6,000 feet high.
Yeah.
And we set it up in November. I think it was November the 3rd. It was snowing that day.
Yeah.
And we went out to test out his planter and planted winter wheat. It snowed 6 feet of snow. It was snowing the day, and it kept snowing, and all winter it snowed 6 feet. In the spring, when the snow went away, that wheat had roots on that far and had shoots green under the snow. So it's crazy how biological interactions the seed is growing. And plus, if it snows quite quickly, it probably didn't ever freeze the soil. Stayed warm under there, certain degrees.
Insulated
But
it.
when it wasn't treated, the other stuff that wasn't treated right beside it when we started the machine up wasn't doing the same thing. So it does actually help plants even when it's cold. But you got to realize the plant is working underground way more than it is above ground, because it's shoot to root ratio, and then when it's time to bolt and to head, it does it, and it's more water use efficient for sure.
So that's why you want to see that higher rate too, because there's no stooling.
Yeah, and it's our it's our energy. It's carbohydrates, in the seed.
Yeah.
So if you just went with a bushel to the acre compared to 2 bushels, you have a lot more carbohydrate. That's energy in every seed for the microbes then to be fed. Because as soon as the root comes out, it's the sugars coming off the root that attract the microbes.
Yeah.
And we've seen it where a farmer in Australia, he said he made a mistake. He seeded twice the amount, and we went out there, and you could dig it, and the roots were far deeper.
It was twice the yield.
It was twice the yield. So if you have not enough seeds, if you go in even any of your fields out here that you've seeded, just go and look at your wheat seed. If the air drill sort of skips, any of those seeds that are by themselves and about this far away, they're a runt. They don't do very well. They're made to be planted close together, and they do far better. Okay?
So in my opinion, like where say you have a canola plant that is all by itself.
Yep.
that
it's a different kind of plant.
grows way bigger because it's got more room.
Yes.
It's not robbing moisture from the other
Yeah.
plants. So how would that?
Canola and corn and sorghum, different plants are different, but it seems like
for cereals.
barley, all the cereals seem to need companionship together.
see.
Where a canola is a weed,
Yeah.
and it'll fill the hole in to keep everyone else away.
Yeah.
Is kind of the kind of plant it is,
I
and
see.
so, but yet you still want to have enough population on canola to smother weeds and be competitive.
Mhm.
If you're really too far spaced, then you could be lucky, it could do well, but probably better to have it at least a really good population. But we find every seed sprouts on canola. People see a very quick steady stand, and insects, and we have some things on here that the flea beetles don't touch it, because if it's high in minerals, no fungus or insect is going to attack that positively charged leaf either, eh?
So what about how much hotter can canola stand?
Well, see, this is where heat blast, when it's flowering,
Yeah.
that nanocarbon actually goes down into the pollen tube and stops free radical oxygen from wrecking the pollen tube. That's really what's happening on heat blast. Very hot day, free radical oxygen comes off, and it destroys that little tube, so it doesn't pollenize all of the seeds in the pod, eh?
But that's what so how much hotter can it stand, like in temperature wise?
Well, this is things that we'll be learning with all of our farmers over hot and
It's still kind of in a
last year was a lot cooler and it was a better year. Where a really hot year previously, a lot of fertilized canola had a lot of blank seeds, and so if we can make it so that every seed is viable in every pod, and this is where at Eckert's down at Brooks there, when they sprayed this carbon water on, they saved from when they were seeding. They sprayed it on at 20% flowering and 50% flowering. They achieved up to 1,000 pods on a plant, and so and every one of them had full seeds in every pod. If we can achieve that on the landscape that you're doing many acres on, and cause them to just hold their flowers on, and that's really heat blast is the biggest thing on canola. I think 2 years ago you probably saw a lot of
2 years
damage.
ago we see.
You saw
Haven't got anything back.
you saw that on canola, the heat blast,
Yeah.
like nothing.
Everything was,
Go to harvest, there's nothing
Yeah.
it was horrible.
there. Yeah, and that is because the plant is probably the free radical oxygen coming off and wrecking the pollen tube.
Yeah, well, it was just too hot for it. And
Yeah.
No rain.
Yeah.
But this whole country was almost in the way of.
Absolutely. Last year not so bad. So
It wasn't. But
Clark in here?
he was, yeah.
No, he's outside.
Well, he let him out.
Well,
so this here is just regenerative agriculture is about mimicking nature, eh? So all of the things that we're mimicking, like I was saying, there's no more buffalo herds that are migrating and pooping and trampling down the prairie grass. So how are we going to do it? Can we get cows on every acre? Like they're saying, regenerative agriculture requires manure. Well, you can't get enough manure, but with the mechanical cow, you've got a heat and pressure like a volcano and like lightning. You have oxidization of very rich oil that used to be a plant, and we're putting it into a fusion tank with the culture of all the microbes, minerals, and carbon together. That is the very same as if a cow is slobbering and pooping onto the prairie, and it's like a forest fire that is giving signals to the environment to regrow quickly again. So it's complete closed loop of managing a fire that you have in that tractor to turn the wheels. Why not use that energy to fertilize your crop? And that's really what we're doing. So it's all about microbes in the food chain eat on organic material and turn it into organic matter, and then they keep eating each other and make it stronger and stronger to be sequestered. And that's where like your soil tests are 1 to 2% organic matter. We want to do a baseline where you are today, because we will increase organic matter by 0.5%. A lot of farms, that have 1%, 2% organic matter is very low, and so to get paid, we want to have a documentation of what your organic matter is today, because it's worth like a 1% organic matter increase could be worth $1,000.
An acre?
Yeah.
It's
like that 1% organic matter is 20 tons.
An acre.
Plus, you know, for every 1% of organic matter, you sequester 20,000 gallons of water per acre. For
Yeah.
every 1%
Yeah.
organic matter increase.
So we're spreading manure right now. We're putting 50 ton an acre
Yeah.
on.
Mhm.
We would be technically increasing our soil by 2% roughly.
Yeah, organic matter out there from the manure. Yeah.
Hmm.
If it stays there, and that's where it's really important to have a lot of good microbiome, so that that manure gets eaten up by microbes and put into the soil
Incorporated
instead of
in.
gassing off. You know, and these are nitrous oxide gas and methane are the biggest greenhouse gases from agriculture. And when we put on too much of it, the microbes try to get rid of it. When we put fertilizer on, they're doing the same thing as the manure. So getting it spread, you know, not needing to put on really big tons on land repeated.
Yeah.
Try and move it around to land that
Yeah,
would be
rotate
further
it out.
away and that
Yeah.
kind of thing. Rotate it more. So that's all about the SOC, the soil organic carbon, and soil organic matter. And like your test is saying soil organic matter, and SOC is less than that. And
Mhm.
so we got to increase the SOC, and it's all about the microbes eating each other. But if you put on fungicide and insecticide, you're cutting this arrow off, eh?
Keep
So
killing
you're
it.
never going to build it, never.
And with seed treatment too.
Yeah, absolutely. Yeah. So yeah, it's just really, you know, closing the carbon loop on the landscape, using what you have, adding a bit of vegetable oil into your fuel when you're planting different plants, and canola. We really see canola loves canola oil, and you know, alfalfa hay. When you're cutting your hay, you might put soybean oil. It's a legume. These are all things that we are learning from our collaborating group. Which is the best fuel? What is the best amount of the carbon water we add to it? When should you spray it? Vaping it under your cutter bar when you're cutting the alfalfa hay will help it regrow quickly again, and that's really, and then it gives you an opportunity during the summer to extract more off to then spray it when it's maybe a week old, with your sprayer. Yeah. And that's how
Yeah.
Edwards did theirs on their alfalfa, and we have some data here showing
How
that it
how
grew
many
9
times
inches
did
taller.
they spray after? On
They
their
just
third
did
pack?
once.
So they vaped it
they
on
vaped.
the disc-bind.
Yeah, and then they sprayed it on just about a week after.
Okay, and then so 2 applications,
They did, yeah,
and that's where they had like an extra 150 bales
yeah,
or something.
yeah, per quarter section, yeah, like twice the yield.
Yeah.
So, and I've seen this in Quebec. Hay farmer there got 100 round bales. Next year, he got 200, and some of the fields they're only getting 20 bales, and they got 100 bales. So it was a real increase on really poor land.
Older
so-
hay ground. that
Yeah,
they
pasture
posted up
land,
too.
all that kind of thing. Yeah. Let's just try the next one here. So then, my question to you is that how much, you know, this is what the agronomy will say, you're gonna mine out your land in 1 year, 2 years, right? 3 years, 4 years.
Yeah.
You're not gonna have nothing left. Well, you know, it's far from the truth, because really, how much earth is in your wheat when you eat bread? How much of that is soil? And how much is it wind from the air? And so NPK and S kind of gets us to believing that the bread you eat is mostly nitrogen, phosphorus, and potassium, and all this NPK and S. But it's all about microbial life releasing and unlocking what's in your soil, because you know, like you've got a million pounds every 3 inches is how much your soil weighs, eh? And a lot of it is all locked up, and the only thing that unlocks it is CO2. CO2 unlocks silicon and potassium. CO2 unlocks phosphorus and calcium. It's the referee that actually, it's like a pair of magnets. When you play with magnets, they repel each other. Now, CO2 can be an acceptor and a donor. In every situation, it can decide to be negative or positive. It can actually flip and raise pH or lower pH. It can do so many jobs in our soil, but we're stopping our plants from taking CO2 from the air and putting it in sugar off the roots to feed the microbes to do the job. So our earth is not working. You know, we own the surface right, eh? And you know, like, are you going to buy more acres that don't work, or are you going to make the acres you have work better? And so if you're renting land, you want those acres to really work. And you know, for 50 years, the farmers have locked it up, and the mine hasn't been working. Your earth is not really functioning, so you're not getting the zinc and the copper and the iron and the magnesium to make your plants healthy and perform, or your animals.
And that's all the food we're eating too.
Yeah.
The food has zero
Yeah.
compared to
Nutrition.
100 years ago.
Mhm.
why is celiac a problem?
That's
Why
right.
are gluten levels
gonna get into
with
that
our
here right away.
GMO levels being
Yeah, and that
Yeah.
relates right back to that nitrate and ammonium feeding 220 positive charged minerals or 59. Eh? It's
Yeah.
exactly because we're force feeding our plants ammonium all the time.
You're making your plant lazy, telling it not to increase photosynthesis.
Yeah.
Really.
yeah, because all we're striving for is
Yeah.
yield.
Yeah,
So
Empty
you
yield.
keep pushing yield,
Yeah.
but because that's the only thing that pays.
Dropping organic matter,
Mhm.
lack of nitrogen.
So my
Unbelievable,
question is
really.
earth, wind, and fire. How much earth is in the grain? How much wind is in your grain, and what does the fire have to do with it? Okay, so the earth is made up of a bunch of little tiny battery boxes. Okay, you take a look at the soil, look at your soil test, and you have CEC right here, cation exchange capacity in your soil test. You said 29, eh?
Yeah.
In that range, you know,
Yeah.
20, 29.
Yeah.
And you said it was sandy soil. Okay, sand is 10, cation exchange. And it's like a very big battery box, but the root only sees what's on the edge of the battery box, and it only holds so much water, eh? And that's why increasing organic matter will hold more water.
Mhm.
And so organic matter is what? 100. And this is your sandy loam like you might have out there in some of those fields, and then
Yeah.
this is clay. And down below, one of your tests said it was 60. Okay, it's very heavy clay. Holds a lot of water, but it's very, very tight, eh? And if you get the battery boxes out of charge, they're like shingles, and no water's going through it, right? And it'll evaporate away. Eh? You know, if it's just down 3 inches, just floods, and then all of that,
Yeah.
that evaporates away, and it can't go through
Yeah.
it. But we got to change the battery's the charge, and CO2 changes the battery charge so that it flocculates, and then the water can go in, and then it's like a big sponge. It can hold on to the water, and then our roots are down 3 feet deep, and that's not going to run out of water on a hot day. Eh?
Lack of CO2 in the soil.
Just that exchange, eh? So this is a soil test at Leader, Saskatchewan. 2.3% organic matter
Which is
is
40
pretty good.
minutes east.
Yeah, that's
of where
right.
this-
Not far.
Yeah.
And yours is at 1.5.
Yeah. 1.8 or something on that.
Yeah, and see your phosphorus there is a 9 or something like that, and this is 8.
Mm-hmm.
So then you can see it's deficient, eh? Just 6 nutrients are available. This is after the first year. It went up by 0.5% organic matter. That's 10 tons of CO2 went into the soil from the plant really pumping sugar. And it corrected all the nutrients, opened up the soil so the water will go in, and raised the phosphorus from 8 to 17. And the agronomist is going to scream at you if you don't put no phosphorus on there, eh? Not going to have a crop. But yeah, right there, 17. It's perfect.
It's all locked up. Calcareous layer,
Yeah.
you just can't get to it.
Yeah.
You need CO2 to release it.
So it's all these ratios on these battery boxes. Okay, so he started out at 1.8. Look at that, 3.3. See, it was deficient at 1 point. It's supposed to be between 2 and 5, eh?
Organic matter went
3.3,
from 2.3 to 2.8.
And magnesium is too high. It's supposed to be between 10 and 15. It's at 20. And went to 17. It's getting better, right? And CalMag was 78, a bit high, and this is 79. It's high, but that's okay. That's right where it should be. This became more perfect, eh? So water will go in the soil now. It's loose. You put a shovel in it. 1 year.
First year, you can bury a shovel
Just like
right through that
on the-
hard band.
The video that I sent you, yeah? Same deal.
Mhm.
You see old layers, eh? And that was a couple, 3 years that Doug been doing it. You know, still break it open and see it,
Yeah.
but it's soft, eh? Roots are going down now.
Gary's ground is 10% organic matter. Hasn't seen fertilizer in 20
So,
years.
Yeah.
and what did you get tests done like 20 years
I
ago?
have done. They were 7. It's by the mountains, and yes, you
Yeah,
can
it
get
is
pretty
pretty
good or black
Yeah.
soil zone. And but we even did, by putting it through the combine harvester, we raised it from 10 to 10.3. Eh? So you can
Yeah.
just
But that
change your
is-
practices.
That's
And
pretty much what it caps out at. Like,
it can.
have you seen much over
We
10, 11%?
Yeah, we did actually bring it up in 1 year when we started using the combine harvester treatment and adding the microbes in, because I wasn't adding microbes in, and we increased in 1 year 10 from 10 to 10.3. So that's 0.3 increase.
Yeah.
That's pretty good.
Still.
Still can move it, eh? But you don't want to go to 30 because then it becomes like peat, eh?
Mm-hmm.
So there's a limit. You want to be burning organic matter and releasing what's in it, and taking advantage of that.
Yeah, and that's
Yeah.
where a hoe drill works better down on your
Yeah.
line because you're aerating,
Could be,
right?
yeah.
You're kind of
But I don't
Letting
think
it
there's
breathe
any
a bit.
harm I don't think there's any harm in this machine, because look at the gases you're putting in properly down in that layer, hey?
Yeah.
And you're spreading it, because I know that a disc planter, you can get seeds right there in that hard soil, and it may not be as good as soil contact, especially going quite fast. It still could work, and if you can get it a good deal, get it, and have a couple of machines going and make the decision on what is the best. But I like a hole like that,
Well,
moving soil.
kind of.
Yeah.
Yeah. After having these conversations, I feel like it might be best to just stick with what we
You've
have.
got it already.
Yeah.
It's
So
there.
we know it. Everyone knows those
Best machine
machines.
right there. And I know if you talk to anyone that's had a disc drill, if they're wore out, you'd be paying new price to rebuild it.
Yeah.
So, yeah, if it goes very cheap, then buy it and spend all winter next year rebuilding it, because you might have to, eh?
Yeah.
You won't have time to do it this year.
Yeah.
If you go high speed, it's not going to take it either. It's made for perfect Manitoba soil that's black and no rocks, no nothing, eh? So I would be cautious, but if you can buy it at a cheap price, get it.
Yeah.
And
Play with it.
Yeah.
Yeah.
okay. So this is in California by the Colorado River, 9 pH soil. And 9 pH soil and 9 pH water, what do you grow? Nothing, right? And farmers go broke, right? They oversalted their land. So it has a 1.5% organic matter. It has you can't see it so easily, but it's got a cation exchange of probably a 40 or something like that.
38.8 just under
38.
OM.
See, yeah, right here. Okay, yeah,
Pass me
38.
an iPad, Carter.
And this land was abandoned, as in they're not farming it.
Couldn't grow anything.
But they had a whole, there's a big lake down there somewhere that just right out.
Yeah, the Imperial Valley of California and Lake Mead. Eh?
Yeah, I
Yeah.
believe that's what it is.
Yeah, and that's right beside all this stuff,
It's
very
turned into
salty.
Salt,
Yeah, and you add fertilizer to salt, what do you get?
Right.
More
more
salt.
So, that's what's happening right down where you're placing that fertilizer. That's why we think it's the plow layer, the old plow. No, it's cement.
Yeah.
It's electrically locked up. And how are roots going to work in that in a drought or even a rains lots? This is the problem we're
Go
facing.
sideways.
So I set it up onto an old box drill John Deere disc planter, eh? And I was planting on boulders. The rock, the soil was like gravel, okay? And I just said, well, just go for it. I'm here, I'm gonna plant this stuff. And it increased it by 3.5. That's 2% organic matter increase in 1 year growing Durham in California, this is Arizona and California, where these farms are. And so,
And because of that, the kind of exchange capacity went up as well, so you got a lot more nutrient holding
sure.
capacity, big time.
and the pH probably come down to 7.7.
Well, you should have a couple of years when basically you get no crop, you might up your.
Well, you'd
Yeah,
still get a
grow.
crop.
Oh yeah, this made a good Durham yield.
They did?
Everyone wondered, what in the heck are you doing?
Well, you'd think the first couple of years.
No, it grew a crop.
First year.
First year in, grew a crop and put that much organic matter into that soil because it had roots, eh? And when the soil is starving for carbon, it can suck it up, eh? Yeah. So it's a lot. 2% is crazy. So talk about yield. Everyone thinks that yield is king. No, it's the profit margin is king. And how are you gonna practice agriculture with less energy? And that's really where on our farm, this has been 22 years since we stopped using fertilizer. And this Durham is under irrigation here at 20% protein. And, it's all about the plant photosynthesizing to the maximum to feed the microbes the energy to fix nitrogen. It takes a lot of energy to make fertilizer. And this plant has to be doing
That's-
maximum photosynthesis.
Especially under a pivot, that's really good because
Yeah.
usually you only get protein when you have a dry year.
See,
10 or 12, yeah. And
where's all the end coming from?
yeah, and it was not, every seed was very plump, and the seed cleaning plant, there was no screenings. And even on dry land, a
Let's
leader,
combine with a gleaner.
yeah, you could.
Yeah, leader there, Darryl Wenzel, he got 28 bushel of spring wheat that weighed 68 pounds on 2.5 inches of rain.
And there was no shriveled.
Heads
no
are full
shrivels.
right to the
It'd be
top.
nice to combine that too, because you're not
Oh yeah.
worrying about tweaking it all the
Mm.
time.
The,
You just
the
blow
fan,
right out.
yeah.
This was 106 bushel Durham right here.
That's on your
Yeah, this is
place.
on our place out behind the shop there. Yeah,
Durham on Durham,
yeah it's
Durham
Durham
on
on Durham
Durham.
too, eh? And I'm going third year Durham to just prove that I can maintain a 20% protein. Doing nitrogen fixation with corn, wheat, oats without buying fertilizer. And why are you buying fertilizer? Like,
Well, it's salt, 68% salt.
it's
is
just
what it is.
expensive energy.
You're pumping salt onto your ground.
So this is the work we did with Montana State University and the National Research Council of Canada. 2 scientists were funded in Canada, down in Brandon, Manitoba, and at Lethbridge. One of the scientists was from Ag Canada, and then we did the trials, and you can just see the soil. This farm had used Bio-Agtive the year before, so that we stopped putting on exhaust and fertilizer. Then we added fertilizer. You can see the color of the soil, and you see Bio-Agtive continuing. It's just oily. So the word soil is S oil, and dirt has no oil in it. So that's what we're doing, is we're putting oil into the soil. And microbes make oil. They have to be fed sugar, then they make oil, and the oil holds on to water. Because every microbe has oily lipids to hold on to water in their body. The more microbes you have, the more oily the soil is, the more organic matter increases.
So I just mentioned the idea to Justin Eckert there. Is there a way you could try and utilize used engine oil?
Yeah, we have added it in the beginning years. Farmers down,
I know
But-
it's a big no-no.
yeah,
but
they added it in straight. You can run 100% engine oil in a diesel engine, eh?
to
A
burn.
lot, yeah.
Yeah.
But it'll be so sooty that they plugged up their system. So
Or you could wreck your injector.
yeah,
Injectors
your,
plug up,
your
yeah.
injectors can be fouled up. But a lot of times, some trucking companies.
But like, I'm wondering, is there a way you could spray it on in a way, and not necessarily run it through your
Yeah,
engine?
you'd want to burn it. It needs to be burned.
I see.
Yeah, raw oil is it takes 30 years for microbes to actually break down and eat the diesel fuel or engine oil. You know, if you changed your engine oil out in the
Mhm.
field, just dump the engine. And
Yeah.
a lot of old time farmers, that's what they used to do, just pull out in the field and dump here and there.
Yeah.
And then later, long time, all of a sudden, that's a really fertile patch.
Yeah.
It takes a long time. That's why it needs
I
to be
see.
oxidized. So the engine's the
I
oxidizer.
see. I
Yeah.
see. So
Yeah.
technically, if you filtered it properly, you could put
A-
a couple gallons.
A
in
lot
every
of
time
trucking
you fill up.
companies actually put their engine oil into their fuel tank.
Lubes, injectors, keeps everything,
Well, 3%, 5%.
and it's a way to get
Get rid of it.
So what if you had like an oil burner in your shop and
Mhm.
you're burning your oil to heat your shop and you
Mhm.
had say one of these systems in there to be
to
producing
capture.
It could, but it doesn't have the heat and pressure. Like that
that you
piston,
need?
that heat and
Gotta
pressure
break it down.
is where those little nanocarbons are made to really do a difference. Yes, you could make something that would stimulate plants,
Yeah.
but not as good as that really,
Is it-
like that
is
Fendt
it-
tractor, you can't
What's
smell the
that?
exhaust
Is that
come out of
thing
it.
still
Yeah.
on?
Yeah.
Very clean compared to this John Deere, but it's completely oxidized, and that's more powerful. Like that when we in California, that was a brand new Fendt tractor
That you're
on DEF system that did that 2% organic matter increase.
Oh wow.
Yeah.
So
It
what does
was.
the DEF system? It doesn't affect anything really.
The DEF system is they're adding in urea into the exhaust
Yeah.
to kill the oxidized organic nitrogen.
Yeah.
So I'm not relying on the tractor to make the nitrogen. I'm relying on this tractor to make completely oxidized things.
Yeah.
And then that is going in the fusion tank to feed microbes, because microbes can't feed on a piece of iron or copper or zinc. It has to be oxidized for them
Right.
to use it, you see.
Right.
So your engine's an oxidizer, and when you oxidize things, you release energy. So then it has energy to run the wheels, and then that oxidized stuff is now a fertilizer to put back into your soil to stimulate microbes. It's just a crazy closed loop that we're involved in agriculture. We're in the best business in the world. Why are we buying fossil fuel energy from our competitor? We are in the energy business. You see, we're in the mineral business because we have the minerals in our soil. But you're buying what? Zinc and copper from the supply company, right? And it's in your diesel fuel, perfectly oxidized. And through your sprayer, you could add a bit of canola oil in it. And when you're spraying, vaping, that you grew on your own farm, closing the loop completely. So this is my Durham. We sprayed it on with a drone, the carbon water. Kelvin and Todd, they had the trailer set up with 4 different kinds of vegetable oil We had canola oil, we had sunflower oil, we had soybean oil and corn oil, because we're wanting to know what is the right kind of oil to stimulate plants. So we sprayed it on our durum. This is the dry land by my son's farm. It's irrigating with a wheel line, 19% protein right here. And this is with the drone on dry land, 21%. And this is dry land, another area is 20.5. So just showing that we're increasing the organic matter from 19.5 to 21.5 by spraying it on.
And protein, yeah.
In protein, and this is under irrigation. This was baked on with our sprayer. This didn't get the drone spray.
Sorry, this one was a.
This was a dry land, and this is a dry land, and this got sprayed with a drone 4 liters at about just at 8 leaf stage, just before flag leaf and stuff.
Okay, so when you spray it on with the drone, you're doing 4 liters, but
Yeah.
no water mixed with it.
No, it's just straight carbon water that we manufactured that we put into the fusion tank.
And so when with a sprayer, say we want to spray it on, are you mixing it?
Yeah,
with
we
water?
we would put RO water in there, and you'd add some molasses, or if you cultured it from your tractor, you'd add 10 liters of molasses to get it to ferment. Then it's ready to go in your sprayer. You add RO water to it, so you might use 1,000 liters. And
so what
dilute it with
rate
water.
would you be spraying it?
I would like 4 liters to the acre of product
But like
on,
full with water.
you'd be 10 or 20, whatever nozzles you have. 10
So what if you use those that airstream?
Yeah.
Yeah, he looked at that
Yeah,
and said
it's
it
great.
worked great.
Yeah,
So you
and
can go with that thing. You can spray it, say 2 gallons an acre.
Yeah, so you could do that.
Or 2.5, I think is the something.
Yeah, I think that's the lowest we've got.
Yeah. So yeah, I think we don't know. Is it better to be like a fungicide where
Yeah.
you're really getting it wet?
Good coverage.
It's a
yeah.
lot like a fungicide because you're trying to cover the leaf to get this carbon, minerals, and microbes. Because these ones that you're making from your sprayer or from your tractor, they protect plants, or they work with plants. And so if you get complete coverage, I'm not really.
Well, see, that's the difference from that sprayer to that. You'd have to test, like, do one field here.
Yeah.
And one field here.
And try different rates.
Try
and all kinds of
different
things.
rates, and like
But
the one
Justin-
missed and the other one just.
Justin did 4 liters of the Bio-Active carbon water that we delivered, that we manufactured,
Yeah.
and that was made with corn oil on his alfalfa.
Yeah.
That's what he used. Yeah, and this is his results. This was last year. You got 20% protein. It's very good. It's got 200 milking. Is 1598 and 190 as far as a relative feed quality. So this is this year, and we got 1666 milk and 210, 219.
relative feed value.
Yeah, and protein is 22 instead of 20, and our soluble protein is 22. So it's just better feed, and this is top end feed. That's higher yet.
Side by side.
Year to year. This is last year's third. And that's this year's
third cut to third
Yeah,
cut.
that's right,
I
yeah.
see.
Mhm.
Did you guys do tests side by
We
side?
have some side by side stuff, tests that they did. The colony did some of theirs, and I think down at McGrath, I have some side by sides. Where he's doing different things, but not really fertilizer. This was fertilized the year before.
Yeah.
That third.
So Justin, on that half section, he did half
With the-
carbon water, half just left it.
That's right.
He didn't get feed tests from either side.
I'd have to find out. He may not have, but he could probably,
Still
if he
gets.
knew. Yeah,
Yeah.
a lot of time. It would be good to know
Yeah,
that
I'd
too.
be curious.
But definitely grew taller.
Yeah.
And that's the tall stuff. That was the stuff that was treated at 22% protein. And this is down at McGrath. This is the 4th cut at McGrath, And after he cut it, the 4th cutting is still, when it chinook the other day, it's still really green, And it actually grew after the 4th cut and recovered, and it was ground covered.
Well, you want to have it recovered a
Yeah,
certain percentage
right, yeah.
for
Otherwise, it could winter kill.
otherwise it'll just
So we're interested to know, does it survive the winter after a 4th cut? A lot of times that's your death, But
It
grew
can
again.
be if
Yeah.
it doesn't regrow, yeah.
That's right. Okay, just go to the next one. So this is at Leader, Saskatchewan at Dale Wenzel's, the canola growing there last year with lack of rains. But you can go to this next one. So these are our yields there. But this is at Eckert. So this is a male and female plant on their seed canola. This is where he added in canola oil at 3%. You just see how much larger that plant is. That's 3 or 4 times larger. Yeah. even just go back, the Bio-Active wasn't getting touched by flea beetles even, a little bit there, but way less there. But the neighbors had to spray flea beetles for 3 times, never got control of it. And if that plant's high in minerals, flea beetles not touching it.
Don't touch it.
How does the canola seed treatment affect
It doesn't seem to affect.
as bad?
It's not like but you don't want to treat cereals like barley, wheat, and oats because they really rely on the fungi.
Yeah.
And that fungicide that you put on seeds, they're planning on you putting phosphorus there, right? Well, you don't need fungi. And fungus is the most limiting thing out in our agricultural land. It's destroyed. It's gone.
Yeah.
But we need to build it back. And fungi like aromatics and benzenes. That's what's coming from the diesel field. They love. That's why pine trees, you can smell it's aromatic, eh? That's they're putting off their roots. That's why they're very fungal.
That's why they can grow on the side of a mountain.
Yeah, and rock.
Just rip apart that rock with the fungi. It will dissolve it, really.
See, the fungus is putting off CO2, and CO2 weathers rock and weathers soil to release the minerals, right?
Yeah.
And that's how cement or a statue gets worn down over 30 years with rain hitting it. Breaks down the statue, right? Or caves in the mountain. It's CO2 that does that work. So it destroys statues and makes caves. In the rain, there's CO2 in the rainwater, and it wears holes into caves, eh? Or when water's running down a mountain.
Don't a lot of plants put off a bit of CO2 at the point of their roots to be able to break through?
Yeah, that's how a root goes through the soil. Is it's giving off respiration, and the microbes are breathing, and the sugar's there, and it opens up soil so roots can go right through very hard soil.
It's right around the rhizosphere.
It
It should be swapping that soil to around 7 so it can extract the nutrients.
Hello.
You
How's
said
it
that,
going? Good to see you.
this is
Yeah.
Cohen.
Yeah, good.
You said that battery, you use it as a battery, is that CEC?
CEC, cation exchange capacity. That's the capacity of the battery or soil. So
Yeah.
10 is sand, 20 is clay loam or
Yeah.
sandy loam,
Yeah.
and clay is up to 50, 40s.
So this one, I'm just looked at completely different area, south of Gleason there.
Yep.
It's 140 CEC.
Holy.
That's crazy. That's really
But
high.
it's like, that's Larry's East, so it's like a really poor land.
Yeah, it's
Tight,
tight.
very
Okay, so
tight.
what's on the percentage of the cations? Okay,
Wait,
that's
sorry?
very difficult. Like, I'll show you. So CCs, that's very, very heavy clay. That's pure clay, eh?
Mm-hmm.
I never seen such thing. This is what's stuck on it. So potassium. This is crazy. Okay, so magnesium. So you're deficient in magnesium. It's supposed to be between 10 and 15. So magnesium is not there. Sodium is not really sodium. Calcium is a 94. That should be about 74 instead of 94. It's highly calcareous, like chalk. Where's your potassium? This is kind of a stupid test. The way they got it laid out. I like to see that too. So, where's potassium? There. Okay, so it's at 17. You got way too much potassium. See, let me see.
Potassium
Wait a
silicate.
minute. No, it's 0.3. So no potassium at all.
Yeah.
In there, it would be going to a drought condition like immediately.
Yeah. Which it does.
Yeah, and so we got to look after this soil. We got to figure this one out. But it's so it's potassium is supposed to be between 2 and 5. You're at 0.3.
Yeah.
Okay, potassium none.
And see, that potassium is very important for pumping water up. And how much sodium's in there? Because if it's on nitrate, you can use sodium.
So sodium
instead.
is quite low. Sodium's at 0.1. It's not sodium.
No.
It's magnesium is at 5. So it's very low in magnesium, very low in potassium, and there's no sodium there. It's just complete calcium, right? Very calcareous soil. Like phosphorus will be locked right up in this soil, eh?
You'll release like 200 pounds.
Okay, the phosphorus is sitting is at 3. Just a minute, I gotta make sure.
Sounds right.
But it says that the saturation is 107%. This is crazy soil.
in
So your
mind.
organic matter is 2.9,
Well, if it's heavy like that, I can see
but
it
it's not
being-
bad for that. The CECs, I would question whether the person who'd ever did the soil test has really did it right. Do you think this is that high? Really, it's got to be like grease. This has got to be the most finest clay you could ever
Well,
get
it's
in the world.
like you drive over it with a truck, and if the wind's blowing, it'll blow it.
But it
I'd
can
like to
rain
test-
out there, it can rain an inch in 2 days, or not even a day later, it's gonna be blowing
Dusty.
Yeah, it'll be dry.
Huh. It's like the cation exchange calculation is wrong.
They could have probed in low spots because it's very up and down.
Yeah.
Hilltops blowing, low spots
Okay,
are great.
maybe his, yeah. I would like to see it test again because a 140
I
is.
think there was a test for the year prior, so
Yeah.
I can look at
Okay,
that.
let's look at it.
I can
wanna-
see up
I
to
wanna see it.
100. I
Yeah.
don't think I've ever seen anything over
That's like
100.
Crazy, wonky.
That's-
That'd be like the best pottery land you could ever get, you know, like for making
Yeah.
pottery, eh? And I don't know, maybe it is there. Can be.
Yeah.
Okay. So it's amazing you're farming it. But the organic matter is pretty good.
Pots instead of-
There's no new business
Feed.
for us, boys.
Yeah.
So this is the canola. Just go back to the canola. This is at Justin Eckert. So he sprayed it on at 20% flowers and got 700 pods on their seed canola. And then it rained and he didn't get done, and so he went back out. It was 50%, and he got 900 pods. So that's getting this nanocarbon on to its growth promoting hormones. So it's stimulating the plant to flower more, and it's also keeping that pollen tube so that it pollinates every seed.
So wait, spraying it that much later.
I'd be interested now in doing a split, doing a bit then and then later. Maybe if
Yeah.
you have a lot of carbon water to try different things.
Yeah.
But no harm in doing it at 50% flower even, and you never know. Maybe after it flowers, you could support the plant to give it another shot. But it all is experimental to know.
Yeah.
So this is the alfalfa hay where he put 4 liters on. He cut it. He has under the cutter bar on his mower conditioner. So every time he cuts, he's then making the carbon water. It's vaping on, helps it when it's decapitated. It's got it on the soil and on the plant. And then he sprayed it on about a week after. And you can see this is the extension of that plant, And I thought, well, maybe it's not nutritious, but that's that hay test. 22% protein, 20%, 22% soluble. So when a cow eats it, it goes right into her intestines. It produces more milk and relative
Just
feed values.
healthier animals.
You said
Yeah.
that they were when he sold some straw to the neighbor, they were just eating this. They were bedding the straw, but they're just eating the straw, right?
Yeah, the barley straw, they grew malt barley, and they used to get maybe 80 bushels at the best on the irrigation. This year they got 100 to 150 bushels to the acre. They cut the barley when it's mature, straight cut, and they watered it 3 inches, and this barley regrew from the roots again, and it was 9 inches tall.
That's
in
where we
September.
walked out.
Yeah, after the
yeah.
field day there. That was unreal how that works. So if you're running cattle,
Yeah.
that opportunity under irrigation.
Yeah,
I've
but no,
seen-
I'm
I've
talking
seen
about the
that.
actual straw.
And the straw from that field,
Yeah.
all the animals are eating it preferential over grass hay.
I've seen 160 bushel barley crop before, but
Yep.
that was we were kind of testing around, but we were seeding it twice as heavy.
Yeah.
And putting down about 3 times more fertilizer
Yeah.
than normal.
And
But it wouldn't ripen it. But we couldn't get it off till like mid-November that year.
I see, yeah. So just wanted to keep
It just
leafy
didn't
and
want
green and growing,
Like
yeah.
retiller.
Didn't want to shut
It would
down.
not die yet.
Yeah. Yeah.
So
This is the
Mhm.
year prior, and there's barley in there.
And
in
is that
20
same field?
Yeah.
And the cattle exchange is 50, but you have some 135. That's down the 24 inches. So there is some. So that's right. This guy would have got it on a hilltop where it blew off, eh?
Yeah, probably.
So it's 56. So that's very heavy clay, and the cattle exchange or the percentages are no sodium, not bad on sodium. Potassium is at magnesium is a 5, so you're short of magnesium there, eh? You're supposed to be 10 to 15, so you're
Mhm.
at 5. And potassium, what the heck? Okay. Parts from that. Okay, potassium is at 1.2. It's supposed to be between 2 and 5, so you're short of potassium and magnesium. Yeah, it's strange kind of soil, isn't it? So you do need some potassium, you do need some magnesium there. I would be interested in just using the emissions and see what happens to this test, you know? If you're,
Yeah, that's kind of what I was
it's
thinking.
not
I'd like to
producing,
use on
this
that.
doesn't produce.
Oh, barely.
Yeah.
Yeah, if you get, well, it actually caught
It
quite a
looked
bit of
good
rains,
until
and it
August.
still only did like 16 bushel canola.
Yeah.
Yeah, I got 7 inches of rain there in June.
Yeah.
Calcareous,
A couple days later, it was blowing dust.
Yeah,
Oscal layer.
it's amazing, okay? So organic matter is 3.7, 3.5, 4%. But it is this very high cation exchange capacity, and that's okay. There's nothing wrong with high. You like it. You got to look at it that it's like a very big battery box holding a lot of charge, and it can get very tight and locked up. And probably fertilizer's not doing this soil any real good because it's high in calcium. So what is phosphorus like? It loves calcium, eh? So it just goes in and not available. The only way you can make it available is the plant feeding fungi, sugar, and the fungi goes out and gives off CO2 to sort out the battery around each root, eh? To release what's there. So phosphorus is sitting at it's 8 pH, the soil, most of it, 8, 7, 9, so it's very high. So it needs this a lot of organic acids coming off the root, and it's got phosphorus there sitting at about a 12, you know, so it's very tied up, eh? Even though you put quite a bit on, you put quite a bit of phosphorus there,
Oh yeah,
like 30 pounds or whatever. eh?
probably something like that in the blend.
Yeah, it's just locked up, eh? It's just
Yes, so.
the only way is the plant around its roots to put off organic acids, and CO2 is what breaks apart the calphos. You have a lot of calcium there. You have phosphorus that's locked up around that fungi. It has to give off sugar and respiration of CO2 to loosen that and release the phosphorus. So I don't know if it's not really making you any money with what you've been doing in the you know, how can you make money with that, eh?
Yeah.
And so the only thing is plant it with the emissions to get that plant maximum fixing sunlight energy and putting sugar there, and it's got good organic matter. I
CO2
think,
break up that calphos layer.
and maybe different kinds of plants too. I'd like to look at that if you send it to me. You know, we can figure out what is the best crop to grow
Yeah,
there,
for
right?
sure, absolutely.
Because some crops will do better than
Yeah.
others, eh?
Yeah.
What has been your experience? What crop?
But
barley didn't do
triticale
too
ran the
well.
best there.
Yeah,
Triticale
sure.
did. I think
And oats,
barley
oats
wasn't.
are triticale, eh?
Yeah, we had
Triticale.
oats there
Yeah.
years ago.
Mhm.
Canola's crap.
No, you don't want to.
Wheat's iffy.
So triticale, rye.
Triticale did the best because he had some wheat on there too, and the wheat wasn't as good as
Yeah,
triticale. That
okay.
was last year.
Yeah.
Well, I'd say something like that is probably a very
I think
powerful plant.
I have we got wheat
Mhm.
plunked in there.
Yeah,
for next
to
year.
this year, but whatever I would look at and consider if there is a crop that really likes that kind of condition,
Yeah.
then it'd probably be better to choose something like that.
Yeah.
Okay.
Okay.
So this is just showing half a liter Roundup on dandelions, half a liter on dandelions with RO water, how it killed. And dandelions are hard to kill at a half a liter, eh?
Mm-hmm.
And it smoked them, eh? And burdocks as
With
well.
half a liter life.
With Roundup.
What
with
concentration?
the RO water. Well, it would be the Transorb Roundup, yeah.
So it's
The high concentration.
The 540.
540
Yeah.
probably.
Yeah.
Mhm. Okay.
That's most of what we use here. I know it's the 540 concentration.
Yeah.
Mhm.
Yeah.
So just the vaping tube that we put onto the boom, and so if you've got the air delivery, we'll be delivering out to there, and it'll just be vaping on, and the engine, we're gonna put the pipe right across and put the fusion tank will be on the back on a John Deere. Has enough, the hood doesn't go forward, all that kind of thing, so it makes sense to put it up front. This will be on the rack. So irrigation motors, we're injecting the carbon, minerals, and microbes into this fusion tank to amplify them at the motor. So at the suction of the irrigation pump, we're sucking the condensate back in, and the pressure is feeding our fusion tank. And then we'll have the carbon water in a tote, and we'll be injecting in a small line to keep microbes in there all the time.
So you You run it right through the irrigation,
Yeah, through the irrigation water. So as the engine's running, it's making
Yeah.
nitric acid, making like more like rainwater. You know, like your irrigation
Yeah.
water is pretty high in of minerals, eh? Because it's
Yeah.
all been extracted by the rain. It's in the irrigation water, and this starts to release it and puts out the nitrogen. So this engine's making nitrogen. And it's making sulfuric acid because it's a bit of sulfur in the natural gas. But you have some diesel motors too that you're contemplating on which way to
Well,
go.
we have, yeah. We're talking about that.
but
one
this
north-
pivot here, that's the one you had noticed.
Yeah, but we got power coming into there, so.
Yeah. And the other
Yeah.
one is just gravity flow.
Mhm. I see. So yeah, I would say spray it on. Make the carbon water with all your tractors and things, and spray it on. So this is in Quebec. So I set this farm up in the spring, and he had it on a small case tractor with a Hardy sprayer. And I put the vaping system on, but I didn't have the right kind of hose material, and so this just got vaped behind the tractor. So you can see the difference of just that vaping. But this field produced 100 round bales the year before, and this year 200 round bales. And then it has another really poor field that was about 20 bales the year before, and it did 100 round bales on that whole area. So you can absolutely see this is second cut, eh? And then just even the grass is growing here, but definitely this vaping that's been stimulated from that engine going on through the vaping machine. You can push it now. This was mixed at a 10-to-1 ratio, but we can go 100-to-1, or we can go straight bioactive carbon water. So if you're doing certain applications, you could go straight strength in there to get a lot of, especially if you didn't do Roundup burn off and you're going to do your first chemical pass,
Yeah.
you could go as strong as
I
1
see.
liter to the acre through your sprayer vapor, right?
I see.
Yeah. And we don't want a tank mix, because
Yeah.
it kills your Roundup. It can do goofy things to your other weed control. So the nice part about vaping is it's separate, right?
Yeah.
Finer and going on to the leaves and all
Yeah,
contact.
so you're saying you could add in carbon water.
At
as well.
100, the straight carbon water in your fusion tank.
Yeah.
So your big holding tank, you could put straight our product in there to get on 1 liter to the acre, or you could be diluted 50% or whatever. It depends on what you're doing.
I
But
see.
You
Yeah,
can
yeah.
get, so when you're out there doing your weed control, plants are this big, you can get 1 liter on that, and then you're culturing this water with your tractor, and then you can take that and spray it on at different stages after you've done weed control. So you can hit it twice, and then you put on 4 liters if you have enough made. Okay, and if you don't have enough, we manufacture more. But I'd like to empower you to make as much.
So
as
how
you
do
can.
you do it?
I
Your diesel?
manufacture it with I use like we have a diesel motor running to cut out all our parts.
Yeah.
And I can use that diesel as our starter.
Oh, I see.
Big
and,
genset.
and, yeah.
Yeah.
So I make it from diesel, so this microbes are used to diesel, so they're coming to you
Yeah.
prepared to. They're not. This isn't foreign to them.
Yeah,
they're
yeah.
not going to die.
Yeah,
And then they go in the soil and they got their food with them. They got the carbon, minerals, and microbes all together, so they're ready to go. Right?
Yeah.
Otherwise, you just buy a rhizobia or something like that, put it on, or a mycorrhizal thing. Well, the indigenous ones in the soil take over and kill them. Eh? These are powerful enough
Yeah.
that they're going to do the work
I
of that
see.
plant. Eh? Yeah. So this is Eckert's corn, like 20 rows, and the second cob had 16 rows. And a lot of that fertilized stuff around had 14 rows, or not even
One cup.
and 1 cob, eh? And this is very nutritious. Like I've tested this at the University of Calgary. It has very high N15 protein, which helps the cow's gut, because that silage would make animals grow way faster, right? Yeah. So more soluble and more, because N15 is like nitrous oxide. You get that in the protein, it gives that gut more energy, eh? Yeah. So this is the side here that we droned it on, and this is where I took the samples. And then that corn, when you're at the field day, I took some of that, and it didn't get foliar sprayed on. It's not as high in carbon as N15. So that's where we're learning. How do you make super feed for your feedlot, eh, or for your cattle, eh? Yeah, more nutritious.
Yeah.
Okay. So these are just things that to be field ready, for carbon trading and that kind of thing. That's where we license every farmer to use us, so we know who's got our systems, we know your land, we know your practices, so then we can market the carbon to people that are industry that can't reduce their emissions.
Yeah. That are buying it.
1 acre of wheat takes in 500 gallons of fuel emissions. So you know how much tax is on 500 gallons of fuel? Like, it's massive. The amount of money, revenue, the federal government's making on carbon tax has to come back to us that own the surface right to put it back in the soil,
Mhm.
right? So that's what we gotta lobby.
So what's the
as a group.
latest with that? Because I know that the government had that
Mhm.
carbon payment in place, and then they kind of backed
Yeah.
out of it.
This is where we gotta decentralize. Forget about governments.
Yeah.
We have to work directly with industry and.
Yeah, and that's where I think
Yeah.
I've heard it where it's going is
Yeah.
is go direct to
Yeah,
someone who's going to buy that carbon credit
Mhm.
from the farmer.
yeah, and
Mhm.
why have the government involved? All they therefore is to take 99% of it
Yeah,
and give nobody anything and
Yeah.
don't make any change.
Give everybody a buck.
yeah, buck an acre.
So
Yeah.
together, we have to aggregate ourselves together as farmers
Mhm.
and
Start
that,
marketing it.
yeah,
Yeah.
that's what Marnie's doing, eh?
I see.
And so we're starting with a no nitrogen,
Mhm.
so that's a huge credit there. And then when the plant has got no nitrogen placed on it and uses our method, it's photosynthesizing more, and we have to, do some preliminary baselines to know what your soil's doing and what your grain is testing.
Yeah.
And then we just we eventually want to have it, so we just test the grain.
Yeah.
We tell by the grain whether you practice our method or
Yeah.
not. Yeah, that's the
And
simple.
then it just needs to get like reviewed and
Yeah,
proven.
peer reviewed, and we have a climate scientist that's doing our program right now.
Yeah.
And so he just needs us to put nitrous oxide meters on the soil,
Yeah.
and then we'll have a nitrogen elimination of nitrous oxide gas, eh?
I see.
And so when we have that this summer, and that's where we got to get these meters, and that's what I was talking to Matt about, whether their research guy has any nitrous oxide gas meters,
I see.
and he's going to check it out.
Okay.
But we may have to buy one for $300,000. Not
Really?
cheap, and they gotta sit there all summer, and they data log, and if we emit no nitrous oxide gas, then it's a huge credit, eh? Because we're not
Oh,
using
I
any
see.
nitrogen fertilizer.
Yeah.
So when
Yeah.
when you put fertilizer on,
$1,000 an acre comes in.
when you put fertilizer on, the microbes are getting rid of the nitrogen. It's too much, and so they give off nitrous oxide gas. And in agriculture, nitrous oxide gas and methane are the only two greenhouse gases we have a problem with. It's because we use a lot of fertilizer to grow our crops,
Mhm.
and all of our soil is giving off nitrous oxide gas, and then
Yeah.
the cows that eat that feed are giving off methane.
Yeah.
So what I'm saying is we increase nitrogen fixation. When you increase nitrogen fixation, the microbe is there,
Yeah.
and it likes this N15, and it puts it into a special protein that when the cow eats, it's more like eating seaweed. And seaweed is high in N15. So if we can get our proteins high in N15, then people's health is better, and that's why people are allergic to wheat, because it's devoid of N15, and the microbes in their stomach are upset. They're fighting in there, and that's why they get sick.
Yeah.
They're not doing the job. Their guts are irritated.
Yeah. And my wife's celiac, so
Yeah.
I know all about
Okay.
it.
Well, I brought some Durham along. Why don't you go eat those bags so you guys can try it?
Is
And-
that baked stuff
Yeah.
again?
Mhm.
Yeah.
That was good.
Did she ever try it? I'd be interested to see if she
Well,
tries.
she's actually I think she got contaminated again, so she's feeling sick right now.
No,
So
not good. Yeah. Not just a little bit affects her, right?
oh yeah, she's like she got the whole biopsy and everything.
Mm.
It's crazy, eh?
The little crumb.
That's all it takes.
Oh yeah.
Wow.
Huh?
She's toast.
Yeah.
All the villi on her stomach lining just
Yep.
abort or whatever,
Uh-huh.
and she can't absorb any nutrients, and
Goes really into a shutdown.
then just
Huh. So
We got guys.
Dale Wenzel out in Leader
yeah,
is a neighbor to Jerry Gill.
yeah,
And he, before he bought the system last year, got some, because I was talking about that ours, was more nutritious and whatever.
Yeah.
So he got some durum and he made pancakes, and
Yeah.
he's able to eat the pancakes.
Yeah.
And I've tested that grain, and it's very high in this N15. So when you test it when it's grown with fertilizer, it's very low in N15.
hmm
So I'd be interested to know whether this is related to that or not.
yeah. We'll see if
So-
she.
So this is
Try
some of the durum that I've roasted, and some hot if you like hot, and regular, so you can give it a try. And that's high in N15.
Yeah,
It's barely hot,
this is
if you don't
hot.
mind. Yeah. So I'm interested in value adding good nutritious food, eh? It's good when you're driving
snack.
or running
Oh, yeah.
running the tractor. It's a bag of that. You'd be good for the day, eh? Todd thinks it's better
Well,
than
you can actually
than a
It is
lunch,
hot.
eh?
just a meal when you eat a bag of that.
Yeah.
Yeah.
That's the stuff we had last time.
Yeah, it's similar.
It's
Yeah.
like buttery flavor.
Yeah, it's. I just roast it and it's fantastic snack food. Eh?
That's the hot stuff.
Your wife would know right away if she ate one.
She can't eat. One time we went to go test some wheat, and I was like, "Oh, feel how wet it is,"
Yeah,
and then her whole hand just got.
Just touching it.
Very allergic to it. Eh?
And then I come home every day and I'm dusty with
Yeah,
oats and
for sure,
even
yeah.
oats and barley has it.
That's the
And
hot stuff.
Yeah.
it sucks because
Yeah.
Terrible.
You wonder, eh? Being
it's
so
weird.
sensitive, Yeah.
It's ironic.
But
'cause
it's
I'm
see,
married to a farmer.
the N15 has a different higher charge to it.
Yeah.
So I'm not sure if it would balance something out or whatever. But if she's willing to,
Yeah, we'll see.
to
I'll
try.
take a little bit home and
Yeah.
see if she's
Mhm.
willing to
Yeah,
try.
I've
She
got
might
some-
want to wait till she's
oh
feeling
yeah,
better.
for
But
sure, definitely. Yeah.
No more?
So
So here are the numbers.
So this is the economics of
Yeah.
purchasing it for a 4,000 acre farm, just as an average. This is a sprayer and a tractor setup
yeah,
on average. This is what you're spending, fixed costs with your fertilizer, and this is probably hard to say how, landscape or what you might be spending $200 on fertilizer in some land. So if you go to the next page, it'll show that when you lease it, put it over 5 years,
Yeah.
4 years, your first year is $10 an acre,
$7.
$17 an acre. Eh? That's the cost to have this system on a 4,000 acre farm. So if you're doing 8,000 acres, $5 an acre or whatever. Eh? But your carbon water has to be calculated, and that's at 2 liters to the acre. Okay. So it costs you $27 an acre. Eh? Okay, just go back.
This one?
Yeah, I need to know what Marnie had on that other. This might be a different calculation.
This is
This is
basically
the
a rundown.
input cost. This is including the carbon water, right? Like the input that goes into your fusion tank, and if you're storing it off, and so your equipment is
time.
your equipment is $17 an acre. You see?
that's reverse osmosis and
Well, I believe she might have a reverse osmosis machine. Just go back to the calculator. She might have it in there, 30-some thousand for it.
I think it's at the I remember
I don't
think
think the
we sent
reverse
it to you.
osmosis is on here.
you sent me one for like
yes.
8,000 acres.
Yeah, that's right. Yeah, we probably did it.
But I think
Yeah,
it was
it's
in
the
a
second
separate
one
column.
down there.
reverse osmosis is in here
They're
at
second
30,000.
Oh, the water
30,000.
clinic. Yeah, it is.
So it is in here. It is in here in this financing.
So but it's in year 2, not year 1. And then you.
Okay,
yeah,
that might be
leasing and
buying it
everything.
a year later. For someone that she's doing this calculation, maybe wasn't going to buy it this year, but bought
Oh,
it
I
next
see.
year.
Okay, so
Or-
$17 really.
Yeah. So if you're even $27 compared to 240, like in this situation, you spend 240 on fertilizer, yield being equal.
And that cost for input includes the equipment, does it, or not?
Yeah.
On your fertilizer side,
No, this is like your
like your bulk
fertilizer.
hauler and your
No, fertilizer, well, not necessarily. I think we do have it, you're burning a bit more
Truck
fuel to handle the
insurance.
fertilizer and stuff. But
Yeah.
there's a lot of hidden costs that we don't maybe exactly, because you need another man to run the
Yeah.
Possibly.
No, yeah, and that's for if you're fertilizing pretty
Yeah, that's right.
heavily.
that's right.
Like our costs aren't.
No,
that high,
you're not
but-
putting that much on, but around here you might, eh?
Yeah,
Around
so
this area,
certain
for sure.
irrigation for sure.
Yeah.
So the return on your investment's 18x compared to 1,
Yeah.
and you can't function on that. It's just not worth it.
Well, it's like the difference of farming 18 years compared to 1
Yeah.
for profit.
That's what it is.
I guess.
20 years ahead.
To catch up, 18 years ahead.
Drop a $500,000 fertilizer bill.
See, farmers
it in
in,
your
in
pocket.
Australia that Calvin worked with, we set up a farmer that had an old quad track case, and they had a little wooden granary for their shop with a power pole beside it. That's what we had to set it up at for the first year. They said in 10 years we're going to build a nice shop and a shearing shed. The first year they had enough savings to build that shop and shearing shed.
Yeah.
And then the next year they bought a brand new quad track for cash. Well,
$1 million or whatever
Yeah.
the fertilizer.
Oh yeah.
it's a return on your investment,
Oh,
eh?
absolutely. It's
So this is carbon. This lady is going to be doing a life cycle analysis for us, and just every farm needs to know. It needs to be a calculation that this is your efficiency of carbon on your farm, how much fuel you burn compared to what you did before,
Yeah.
right?
And going back to that 18
Mhm.
ROI,
Yeah.
that's not even including potential carbon credits in the
No,
future.
not at
No,
all.
no,
Uh-uh.
no.
And that could be
Oh,
That's a separate
Double.
business
we get
altogether.
that. This is an actual rocket
Yeah.
with a torch under it. Eh?
yeah.
Yeah, and that's
You could
where.
retire in
we have to
5
go.
years.
Completely different business.
Yeah, or you could actually farm the acres that there's only 2% of us are farmers. Well, how are we going to feed the world when we're walking off the farm, eh? So you got to turn that around.
What are you gonna do when there's a massive influx of people in the city moving out? Like
This
there's gonna be
fall
a
over did you want to do?
like what's gonna happen when there's a massive migration from people out of the cities into the rural areas? That's gonna happen, and you got to be able to afford to pay these people to run a good operation. Like to take on 4 extra employees is a big payroll. That's
Yeah, like is it going to collapse or is it going to go successfully going
Yeah.
forward? And we need 3 businesses. We need the real estate. You own the land. We need the food security. You're growing good, nutritious food, and we need a carbon exchange. And that's really what we believe, and that's why we're aggregating these farmers. We know that the farms we're servicing this equipment, and ongoing connection. And that's really what we do with farmers around the world, and that's why we're aggressively going to be marketing carbon.
Yeah.
And
Yeah.
no one else can put carbon in the soil like what Bio-Active can do. So,
Exactly.
Yeah.
It's
So is that pretty well it? Is there another one or two?
There's
Just whirly birds that the world's paying, $1.6 billion for this idea. Oh no, they're not gonna suck up
to
the carbon.
capture carbon.
Yeah. And their goals is like enough, like 500 acres of your land will do more than this
So
machine.
where are they putting it?
In
Just
the mountains,
ground?
a lot of this stuff is in Greenland and Iceland, and
Just to store
they're pumping
away
it down
and-
in the soil. They're using a lot of water, getting the CO2 from the air in the water and putting it in the soil. But you know what?
It came from somewhere, so why don't you put it on the farmland?
That's the thing. It's a business. What we're saying is that it's creating a business for you to employ many people. This is not creating a business within the business, eh? This is
Making
just
them money.
just putting it in the soil and it's gone. We need the carbon. We need the carbon in the
Yeah.
soil and not deep in the rock.
Yeah, exactly.
So we need it through the plant, and that's really what this is showing, is that, instead of buying the nitrogen fertilizer that's going straight to the atmosphere, we're working with the biological cycle so that within the plant and the sun, we're storing carbon long term, and that's really where the fertilizer nitrous oxide gas is the 300 times more powerful as a greenhouse gas than CO2, and methane is 20 times more powerful. This is the one we have to look after in agriculture, and it's because we put fertilizer on right there where it's converting from ammonium to nitrate. It gives off nitrous oxide gas, and that's where you lose is volatilization. This is where you can lose 75% of your nitrogen fertilizer that you bought is in volatilization and causing climate problems. Yeah. So so this is the work we're doing at Olds College on the pastures, and Bionutrient Association is doing the nutrition that's in the meat, so that we can show that it's a more nutritious steak, and so that's value adding and
Oh yeah.
selling to people in Calgary that they know that yours
Absolutely.
is the best
And that's
tasting
where
beef. Eh?
that's where the food industry is
It's
going.
going, yeah.
Mhm.
Oh, for
Everyone
definitely.
wants to trace it and
Yeah.
see what
Yeah,
exactly
I
is in
know.
the
And
food.
come right to the farm and see those animals and believe in the science behind what we're
Yeah.
doing, eh?
Yeah.
So it's all about phytochemicals, and that's all from the plant being right and the microbiome being right, the cow eating it, her guts working right, and getting it in the food chain.
And even us humans feeling better.
Oh yeah,
Not
Oh yeah.
not sick all the time,
Yeah.
or have a cold every second week or whatever. So the hog exchange as well. Most people with hog barns are subsidizing their hogs. They're not making any money.
Yeah,
The
make it
packing
1%.
plant makes all the
Yeah.
profits, and same with the beef, eh?
Yeah.
So we are a Musk Foundation team. We put the application in, and 2024 we want to have it so that we actually achieve this on all of the acres of land that we're doing to get the higher carbon credits and get it verified, and that's why we're funding Wolves College to do the research for our 2024 trial. This year, we got to get it right, and next year we'll have the demonstration that we don't emit any nitrous oxide gas. The cattle don't emit methane. So CO2e equivalents, we will be building carbon in our soil. We won't be emitting any nitrous oxide gas, and methane from livestock will be under control. And that's what we want to do by 2024. We can do it. You guys all have the landscape and the cattle and the soil in your tests from before, and the tests a year later will show that difference. Right? Yeah. So I put in a application for the Alberta Central Innovation Award, and we did win this competition, and and so we're started a bank account at the Vision Credit Union, and they're all across rural towns, and so that's where we'll start our CO2 exchange carbon bank. Eh?
Oh, I see.
See, it's like a bank. So what you would do is you have 1,000 acres. You put that into the land bank, and then every year you would sell the carbon credits from that, or environmental credits.
Oh, I see. Yeah.
And
yeah,
so
yeah.
then you own a share.
Restoring it.
Yeah, and every year this bank is generating carbon credits that pays you because you're registered to those acres. And that's really where we have to have it.
And the sooner you can do that, the better.
Yeah.
Because every year you're losing out on it.
Yeah, and we can retroactive back to 2020 if we do this nitrous oxide gas, because we know our farmers, we know their financial records, because our license agreement allows us to get verification from the farmer.
I see.
Did you buy fertilizer or not?
Yeah.
Well, if your records show you didn't, and we have a independent verifier that does this, then you qualify for no nitrogen fertilizer use, and then we'll be testing, getting grain samples, and we tell that it's high nutrition in the stable isotopes, and people will pay more for this kind of
It's just
grain.
the tip of the iceberg, because I
It
went
really
to
is.
Nutrien maybe a month ago,
Mhm.
and they were talking about carbon credits, and basically, big corporations that can't offset need to start buying these, but it's like I don't know, $30 an acre or something that, but they're thinking it could be going up like 5 times as high.
Eventually
Well,
it
you're
will.
sequestering between 5 and 10 ton carbon per acre per year.
Yeah.
$200 a ton,
But if you're using fertilizer,
Yeah.
you can't build soil carbon. It just doesn't happen.
Yeah.
Plant physiology isn't set up to do it. And so Nutrien will have to buy carbon credits from you, right?
Yeah, I don't think it
Making
was
that
them,
change.
but it was just a speaker
Yeah.
there.
That's what they're talking about, but they don't want to hear.
Well, they want to get in the middle of it, I think,
Oh, yeah.
too, maybe to.
Well, they want to make 75% of the
Probably.
profit. We're going to do it independently, no middleman, from your farm to the buyer, and that's what the CO2
Well, then
exchange
where's
bank
your
will be.
what? You don't make any money out of it though.
We would make an exchange, a verification, and a aggregating fee, but
Okay.
75% of it needs to go to you, right?
Yeah.
Not the other way around.
Yeah, I see.
So we got to work on all those
Yeah,
scenarios, but it's farmer owned. It's like a co-op, right?
Yeah.
You deposit your acres into the CO2 exchange bank,
yeah.
and we have to sell it like
Well, then you just start
50,000
marketing it.
acres, and we start
Oh, yeah.
marketing it. And big industry, we have enough,
Oh, yeah.
and it's
And for
credible.
those big industries, it's a perfect marketing tactic for them because
Yeah.
they're green, they're friendly, they're offsetting.
They're supporting
Absolutely,
farmers.
they're offsetting.
And those big,
Yeah.
big industries,
Mhm.
$1 billion to pay out for carbon credits is nothing. For
And
them.
they've got to
No.
look good. They
Yeah.
got to get a better corporate image, and that's what they're looking
Yeah,
for.
exactly.
And they'll do it voluntarily, and not wait on the government that's going to tax them to do nothing.
Yeah, for sure.
So that's where we're at right
Yeah.
now. We're right there. We're talking to the oil industry. We're talking to the forestry industry, and together we have this network that we're setting up because
Yeah.
we have
Mining-
ag tech solution to the
mining's a big
problem.
Hmm.
So this is the drone that Kelvin flies, and we did a lot of experimenting this last year. Does that actually play? Sound like it? Yeah. So the Nuffield scholars came from different farm guys that get it funded to go around the world, from Ireland and Australia, and I'm not sure where all they were from.
Britain, yeah.
Britain, yeah. and they've come to our farm quite a few times. Harold Perry, you know, at Chin, they have the domes there at Chin, the potato growers.
I don't know.
Yeah, he's
East of
been
King.
involved with us quite a few years, and he brings his Nuffield scholars to our farm. Is this the
How
drone?
many liters does that drone
That's a
hold?
20 liter.
20 liter.
So you can do
Depends for
10
yeah,
acres?
yeah,
10 to 15.
yeah, and quite quickly.
Pretty
And
quick.
getting on, so this is where we got 22% protein on this durum, eh?
That's cool.
And so then this is all of the samples, grain samples I did on our farm this year, and sent them to the University of Calgary and some of the other farmers too.
Yeah.
And then we get the results back. And this is so when you put fertilizer on NH4, this is like a pipeline, eh? And this is the big leak of nitrous oxide gas that goes up to the atmosphere. This is what you're losing, eh?
Yeah.
So it comes out, and then it goes to NO3, and then if it floods and gets too wet, then you can denitrification can happen. But right here is where most of it's happening with NH4, and so if you don't add any NH4, you might have a bit of protein in the organic matter and stuff that might give off a bit of this nitrification and or denitrification. But microbes are right here trying to fix nitrogen again, so they grab onto that N2O and put it into a special protein, and this is enriched in N15, this N2 gas. That's what they put in a racing car because it's got a lot of power in it. And so that's why we want to have the microbe fed a lot of sugar, so it's fixing this N2O back into a protein, and that's what makes the grain not give you allergic reaction. Like this durum here has probably a 3 enrichment of N15, where fertilizer would be a -3. So that's the difference.
Yeah.
There's more power for your microbes to actually digest it and not upset your gut maybe.
So as soon as you get these tests peer reviewed and it's approved, then all the carbon credits you'll start storing.
Yeah, we're actually going to be able to retroactive back
Yeah.
to 2020.
Yeah.
So even what we do this year, we want to be getting all that data from information from you, and it's really knowing where the land is, and if it's a rented land, we have to have figures of how much would go to the landlord, how much would go to you that owns this equipment,
I see.
and those kinds of things we have to work on.
For sure.
And we need to collaborate with you to
Yeah.
understand what does your renters think or expect,
Mhm.
but it can help you rent land, eh?
For sure.
If there's a carbon
Absolutely.
credit.
If you can pay someone to rent their land and give them a good payment that keeps them happy, and you can still make $1, that's
Yeah.
big.
So that's what we
ahead-
wanna work
ahead-
on. We
ahead
gotta
of people.
Talk about all this stuff. That's what
Yeah.
our Zoom every Thursday in
Yeah.
the morning. We do this Zoom to try and brain with our whole bunch of groups.
Yeah,
And
yeah.
everyone's a member. We all have a license to use our technology. You have the equipment. You're doing the practice, and this carbon credit will blow away any potential of what you might make on a wet year, dry year. That's where we gotta start.
Mm-hmm.
Yeah. So this is a 5th growth at McGrath after cutting the 4th growth. Eh? Look at the neighbor, eh? They've got 2 cuttings probably. Yeah. He's never got a 3rd cut before. Eh? So this is at Eckert's. They got a fent there. This is at our field day when you guys come over.
Yeah.
And we've got a new kit that's going on there in the next week or so, and on the corn planter, and definitely corn. If you could grow corn in areas like this under irrigation, your tonnage, your food value for feedlot or whatever, can be huge. Eh?
Or C4 plant,
Yeah.
tropical plant.
Yeah.
Really responds to
Roots
plant
just go straight down like pencils, eh? To build carbon probably too, eh? Yeah. More.
Yeah.
That's pretty well it. This is our factory. We're scaling up to, it takes a lot of support, a lot of training.
So do you
Employees.
use this stuff on potatoes yet?
Yeah, we have done it down at Tabor, and definitely potatoes.
That's where more potatoes are, is Tabor.
Yeah, that's right. Yeah. So,
How does that work?
well,
Potatoes?
Starch.
It-
We
No,
make,
Shane-
we make starch like
Bottom
crazy.
there, Shane Schaefer's canola crop there, just
Right here
magnificent crop.
and this was flooded out. This up by Edmonton, they got way too much rain, and he sprayed on about 3 times the carbon water and recovered that canola that was flooded. Eh?
Yeah.
Yeah.
This must be
This is
Sedgwick, eh?
Laverne
Sedgwick,
Billy
yeah.
at Sedgwick. So he's made silage round bales and sprayed it onto the silage, all kinds of things. Yeah.
130
Yeah.
bushel barley crop
Yeah.
there, yeah.
And
So this is down at McGrath. This is the hay that Todd has bought from the guy in McGrath.
I feed this
Feed
hay
his
and
horse.
it's unbelievable hay.
This
You,
got
get-
the
you
kit-
feed half of it,
kit
half as
mounted on
much
the
as
swell
normal.
there. Some more better feed conversion, eh? If the guts are working, you're going to get the nutrients out of it. Plus the nutrients are in that hay. Yeah. So this is that
30
leader.
bricks. That's a,
Yeah, like right up 30. Usually it's 7, eh, with fertilizer, eh?
bricks was 30.
So it's photosynthesizing more, making more sugar.
Yeah.
And the soil's like fluffy, eh?
Soybeans.
So this is
too.
down in Ontario, and see 6 nodes of soybeans. Yeah. So about 80 pods on a plant instead of 30. Eh?
So it out yielded fertilizer on that.
Oh yeah, you know, like
It's,
Yeah.
you know, we're equal to
Oh, yeah.
or better than,
Oh, yeah.
but most, everything we saw this year was better than.
now with the
I'm sure, and it's only the start.
yeah, this is the second year of really starting to work with the microbes added to the fusion tank.
Yeah.
And it's absolute now. When you put it on, those plants are growing. Like look at this in Quebec. This is usually with lots of rain that's just washed out. The cows are skinny, but this year, absolutely, he says they're happy and fat and growing properly. Where you get too much rain, it just washes all the nutrients out. So this is down in North Dakota, soybeans and nodulation. They had 3/4 sections of land that was salty and not growing anymore. And their son works for John Deere, and he's coming back to the farm.
Really.
Yeah.
Because those land's productive now.
Yeah, can grow corn. They grew corn
There's
there.
places that you've never grown anything.
Yeah.
And all of a sudden it becomes
Like Chester Bogey down,
productive ground.
Chester
yeah.
Bogey down at by Dutchess there.
You deal with Chester?
Yeah, he's bought one.
Well, you know,
Well,
Chester, huh? Sounds like everybody knows Chester.
It seems like it.
Yeah, so
We were at a,
you work for Chester?
No, I've never worked for him.
Yeah.
I just grew up at Hannah, so.
Okay,
yeah.
good. Yeah. So you know the King Cots out there?
I don't know them, nope.
Yeah. So they bought a system as well, like for their corn planter, tractor,
Yeah.
sprayer, the whole bit, and Chester as well.
Yeah, no, I grew up at Hen Hills Lake, right beside
Okay.
the lake there.
I see. Yeah. Okay.
yeah, we're setting up a farm there in Hannah, King Cots, full farm.
So it's just a review of what we saw, eh? Just hydrogen, and this is hydrogen and CO2. That's what stores sunlight energy. Eh? Go back to the other one. Just hydrogen, no energy. So you never store the sun's energy. It gets stored. So when they make fertilizer, right here, they take in light. Light is in the natural gas. They take it and they take air, and then it's just like an engine, heat and pressure makes the nitrogen molecules break apart. The dinitrogen is the most powerful connection with two molecules stuck together. It takes like 900 kilojoules of energy to split it. That's why lightning splits it. That's why in this factory they got to use a lot of natural gas to put heat and pressure, and the sunlight energy from a long time ago gets stored in the nitrogen molecules. Eh? So when you put it on, that plant says that's sunlight. Eh? It's free energy. So then it has to kick off the hydrogen off of its roots, and it slows this plant down at making sunlight energy turn, CO2 and hydrogen makes sugar. Right? So you go to the other one. So see, this plant is maximizing its attraction of the CO2 into the lung because it's got zinc, especially zinc on the edge of the leaf. That's what actually attracts the CO2 in. And that's why if you put phosphorus on, what do you have? A zinc deficiency, right? And so you have a highly positively charged leaf taking in the CO2. The sunlight energy is splitting water, H2O, eh? So that where oxygen comes out of the leaf is from the water. It's not from the CO2. The CO2 is what it joins onto this hydrogen and makes it into HCO3, which is sugar. And that's flowing out and feeding the free-living bacteria like a legume on corn roots or wheat. They're out in the soil, or corn has associated ones right alongside the root. Wheat works with the ones that are more out in the soil, and a nodule of a legume will have it right on the root. So we're mass flowing sugar out of the roots on wheat and whatever to make 20% protein, and it happens, eh? So you never have to buy fertilizer again. Yeah. And phosphorus is in our soil. We just need fungi. We have no fungi because we're using phosphorus fertilizer. The plant is not. Go back to that drawing. Fungi, it's made to find phosphorus. If this plant is satisfied for phosphorus, it ain't feeding no fungi because they're a parasite, eh? And they find water. So they'll extract water out of every little nook and cranny in your soil, like 10 times further from the roots and far more efficient than the roots. Eh? Roots can't really do the work. It's microbiome. The microbes do the work, and that's what we're empowering. Eh? So it'll find phosphorus, and it finds all the zinc and the copper in there and the magnesium, and brings it back, and it tells the plant, okay, I'll give you all this minerals and this phosphorus, give me some more sugar. And so the symbiotic relationship is going like crazy. And this makes oil. It makes glomalin to make your soil hold together and not erode away and keep it flocculated and all that kind of thing.
Organic matter.
Yeah, that's what it is. But do we have it on the other picture? How are you going to do it? It's getting worse, eh? Yeah. Yeah. So that's what we deliver. It's the starter, right?
Yeah.
And it's used to diesel, and we make it with all different kinds to experiment with different things for different plants. And you're putting in your tractor, they might add some canola oil or whatever into your fuel at about 3% for canola. And we'll learn from different experiments with farmers what they do. Yeah. Okay. So
So you use,
questions?
you use used oil or?
I would not
Canola
use used oil really. It can foul up your injectors. You could use a little bit.
I'm saying used canola oil.
Oh, I would
Like the
just
stuff that you mix.
I would buy it from the grocery store. I buy it from Costco.
I
Nice,
see.
clean, filtered, easy to use. Yes, you could use restaurant oil, but yeah, you gotta filter it. There might be water in it. There might be whatever. So you better just use from Costco.
Yeah.
Yeah. So that's pretty well the story. We're gonna stick to it, eh? Practice it.
Yeah.
Everyone, it takes psychology. We believe in what we do,
Mm-hmm.
but when you understand how plants grow, well, why am I doing what I used to do?
Yeah.
You know, that's the thing. Yeah. And so we can help you practice it. We have the kits to do it, and just can help you out, get a lease or whatever you need to do.
Yeah.
Okay.
Cool. Well, I really appreciate it.
Yeah. You're welcome. Man.